let me show you one more example of hybridization. Let it be SF6, right. So here the central atom is S, so I am going to write the atomic number for S1 first. It is 16. Now it is a turn to write the configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p4, right. 10, 11, 12 and 4, 16, right. As you know that only the outer shell, valence shell participate, that means this is going to participate. So I am just going to make them in an orbital diagram. 1, 2, 3 and this is my 4. This is 3s and this is 3p, ground state, right. And we do have the vacant 3d because there is no electron here, but still the shell is present, so we make 3d. Now when we excite, what happens? This paired electron and this paired electron get excited to this and this. So let us make it the excited state. Right. So that means this paired and this paired electron is now here. So that means it can, it has now 3, 4, 5, 6, 6 half-filled orbitals and it can accommodate 6f. So this is our F. So it becomes, what is the hybridization? 1s, 3p and 2d. So comes out to be sp3d2. Now as far as the shape is concerned, you are going to total it. So 3, 4, 5, 6. 6 means 6 neighboring atoms. 6 neighboring atom is the octahedral shape, right. So then we are going to make it like this: S, F, 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 and these two are the bonds. And if we talk about angles, so the angles are all are 90 degrees, right. So this is going to be that how you are going to prove this SF6. So likewise, when you will make a hybridization for NH3, you will see that the N, as you all know, that N has 7 electrons. So when you write the configuration, it will be 1s2, 2s2, 2p3. That means 2 electron in 2s and 3 in p. So here there is no vacant orbital and moreover no excitation can take place. So how it is going to accommodate H? 1, 2 and 3. So that means this H, and what about these electrons? This will last as the lone pair. So that means it is again 1s and 3p hybridized, but the difference between this and the CH4 is that here there are 2 lone pairs, so that they will be indicated here, and moreover the geometry will get little how distorted. That means the distorted tetrahedral, because there is a repulsion between the lone pair, we know that there is a repulsion between lone pair, bond pair and bond pair. As you can see in this case, there is a repulsion between lone pair and bond pair. So the angle from 109.25 gets distorted, and it is something called as distorted tetrahedral, and there is a special name for it called as pyramidal geometry. So this is how you are going to perform hybridization, and as you saw in this case, the excitation is not a compulsory factor. Even the half-filled and fully orbitals can participate, right. So this is the hybridization.